Today we're going to be talking about congruent figures. And when two figures have the same size and same shape, they are called congruent. So what we're going to be doing today is we're going to talk about corresponding sides. The side that's marked with one mark in triangle ABC, AC, is congruent to the side in the other triangle that's marked with one. So that's going to be FE. And similarly, side AB, since that is marked with two hash marks, that is congruent to DE. And similarly, the same corresponding side BC is going to be congruent to FD. So those are our corresponding sides. Now the corresponding angles. Angle A is marked with 1, so that's going to be equal to angle E. Angle B is congruent to angle D. And lastly, angle C is congruent to angle F. Now when you're naming the congruent triangles, say we have listed it as triangle A, B, C is congruent to a different triangle. The order matters. So I've said ABC, ABC. I went from 1, so this angle in the other triangle that's congruent to angle A should be listed first, so that's angle E. And next, I've listed angle B, the angle in the other triangle that's equal to angle B, angle D should be listed next, and lastly, F. So similarly, there's another way you could name it. Say I said triangle BAC. That's going to be congruent to, I started with B, so I started with 2, so that's D. A is congruent to E, so that should be listed next. And then lastly, F. So that's just two ways. There's more ways that you could list them, but that's just two of the ways that you could list the corresponding sides and angles. So looking at this statement now, I can say that angle B is congruent to angle D, just by looking at that statement. Okay. So now, corresponding parts of congruent triangles are congruent. This is going to be a reason in proofs. Corresponding parts. So name our corresponding parts. Let's do our angles. Because corresponding parts of congruent triangles are congruent, angle M is corresponding to angle P, because they're listed first, so those are going to be congruent. Angle L is congruent to angle J. Angle R is congruent to angle N. Our sides, our corresponding sides. ML is congruent to PJ. I listed the first two letters together. LR is congruent to JN. And lastly, MR, the first and last, is congruent to PN. Okay, we're given some points. Name the coordinates of G such that triangle ABC is congruent to EFG. So let's plot triangle ABC. So I have the point 1, 2. That's A. B is 4, 2. 2, 3, 4, 2. Label that guy. And C is equal to 2, 4. So now we have these. This triangle here is going to be congruent to EFG. So E is equal to 5, 3. So that's point E. F is 8, 3. So I'm at 5, 6, 7, 8. So therefore I know side AB is equal to EF. Those are 3 units long, and that's the correct corresponding pieces. I need to find where G is going to go in correspondence with C. So from A, I went up 2, right 1. So I'd go up 2, right 1. There's one possibility for G. So one of our possibilities is 6. And I went up 1, 2, 3, 4, 5. So that's one possible triangle. Now there's more than one possibility. G, I went up 2. I could go down 2. That's another possibility for G. There's another triangle. It's just flipped around because it has the same size and same shape. So those coordinates are going to be 6 and 1. Next, suppose we're given a scalene triangle and a point P on some line L. How many triangles are there with one vertex at P, another vertex on L, and each triangle congruent to the given triangle? So you need to think about this now. And on my next slide, I have a picture. So I have point P. I have line L. I need to now look at how many triangles I can have so that one of my vertices is at P. Okay, but one of the vertices is at P, another one is on the line, but so that how many triangles do I have? So let's just worry about putting this vertex at P. I know I'm going to have 3 vertices, so I'm going to take this answer, I'm going to multiply by 3. So if I take that vertex, what if I were to flip that around? There's another possibility. Let's flip this around another way. There's another possibility. All right, let's flip this again. Flip it, and then flip it again. So that's 4 vertices. There we have 4 vertices, or I'm sorry, 4 different possibilities with that at point P, that at point, that on the line. So I'm going to have 3 vertices times 4 possibilities for each vertice, but you could also have that vertice up here on the line. So that's, I then now need to multiply by 2. That gets me my grand total of 24 triangles. So part of this, the challenge, is figuring out all of your different possibilities. There are your lesson questions for the day. Please make sure those are submitted on time.